Water regulation. Why do we care about it? Well, we care about it because of the numerous things in your body it helps control. And if you don't regulate it, the numerous things that get out of control. So let's take a look at that in this video. Water regulation in your body is based off of osmolarity. Now, osmolarity is the amount of solutes dissolved in water. So things like electrolytes, salts, those are dissolved in the fluid. So all these ions dissolved in water, your body is going to regulate and control the amount of water in your body based on those levels and those concentrations. So if we're looking at this, you're saying, why do we care about water levels or salt levels or solute levels? Because almost every one of your body's systems needs to have certain ions, certain electrolytes to function properly. And you got to make sure those ions and those electrolytes are delivered to those systems in proper amounts and proper proportions. So we have to make sure we regulate the amount of water in our body so our blood can do all of this. Not to mention the other systems that it functions for as well. So we'll start with the hypothalamus and the kidneys. Now, the hypothalamus is up in the brain. It's going to help with your thirst regulation cycle. So it'll help you know, are you thirsty or are you not thirsty? What ends up happening is the hypothalamus is constantly monitoring various different sensory neurons in your body. And if those different neurons are sensing there's an imbalance in the osmolarity, so there's too much salt or too little potassium or not enough chloride, whatever it could be, if any of these ions are out of balance, it'll tell your body that, hey, your conscious part of your brain, I'm thirsty. Or tells your conscious part of your brain, you're not thirsty. You don't need to drink anything. You've got plenty of fluids. But that works in conjunction with your kidneys, because your kidneys are constantly filtering through all the blood in your body. And when I say constantly, they're just doing it 24 hours a day. They don't stop. So this is telling your body, hey, we need to either drink water or not. Because you're looking at the amount of solutes, the amount of electrolytes, the amount of ions that are present in there. All right, how does that work? Well, one way is across a semipermeable membrane. Because a semipermeable membrane, like the name implies, some things pass through, some things don't. Those ions that are dissolved in water, those electrolytes, sodium, potassium, chloride, different proteins, they can't simply pass the membrane, but water can. Water has these channels, these proteins that are called aquaporins. Now, the aquaporins allow water to flow from high to low concentration easily, just passing right through, no problem. What's not allowed? All those solutes. They can't simply pass through because only water can go through the aquaporins. So we have to get into that a little more, but let's take a step back. Before we figure out all this production of water and how you manage it, let's look at how you gain and lose it to start with. Because you have to take water in and excrete water on a daily basis. If you look at the water loss, you lose about 2.5 liters of water a day. I say about because some days it's more, some days it's less. It also depends on your activity levels. If you're out on a hot 85-degree day and you're exercising for an hour or two, you're going to work out and lose a lot more water than if it was a 50-degree day and you're sitting around doing nothing all day, relaxing. So that 2.5 liters is just a ballpark. It varies depending on person to person. Some of the water loss you're not even aware of. When you're breathing, you're exhaling water vapor. If you've ever been in a cold enough climate, let's say 0 degrees out, 10 degrees out, and you exhale out your mouth, you'll see all this water vapor come out. But then if you exhale through your nose, You won't see it, or maybe see just a little bit. That's because breathing out through your nose actually helps to reclaim some of that water vapor. So for individuals that are more mouth breathers, they're actually losing more water vapor in a day than someone that's breathing out their nose all day. Or if you're talking a lot, like right now I'm giving a lecture, this is causing more exhalation of water vapor as I'm talking. Sweating. You might think about it, but sweat can add to a lot of water loss in a day. You're saying, well, I'm not exercising. Even not exercising, there's still some water getting to your skin. So that's the water loss side of things. Obviously, no, urination is also water loss, but that's a conscious, you're aware of that. How about the water gain? You can gain water through several different ways. One happens even if you try to sleep all day. Your metabolism. Metabolism is the chemical reactions occurring in your body to keep your body alive. There's about 300 to 400 milliliters of water gained from these metabolic reactions. Reason being is water is a byproduct of these chemical reactions. Now, if you have a little more metabolism going on, maybe you're working out, you'll gain more water. But if you're working out, you're also losing more water, heavier breathing and sweat. So it's kind of a wash there. You'll get about, give or take, 700 milliliters of water from the solid foods you eat in a day. Now I say give or take because it depends on what the foods are. If you're eating a lot of fruits and vegetables, you'll gain more water. If you're eating a lot of things like nuts, you're not getting as much water. So it depends on what you're eating and what is there. Even within the fruits and vegetables, things like, for example, cucumbers, grapes, very high in water content. Things like bananas, not quite as high. Not saying any of those are bad by any means, but they have different levels of amount of water in each one of these items. So that 700 milliliters based on solid food of water, that can vary quite a bit depending on your diet. But it's also important to make sure you do get the fruits and vegetables to help out with that. Which leaves about at least 1.5 liters, so 1.5 liters of water to be consumed in a day. Now with that being said, that varies from person to person. Some people need more water. It just depends on how their bodies process and how much they need. There's kind of a rule of thumb, it's not really anything official or not, but if you take your weight in pounds, divide in half, that's about how many ounces of water you want to ingest in a day. So if you're, let's say, 200 pounds, divide in half, 100, give or take about 100 ounces of water in a day. Now that 1.5 liters I mentioned, that's a little over 50 ounces of water. So you can see there's quite a big gap there depending on what recommendation you're looking at. And depending on what that recommendation looks like, you can have a lot more water or a lot less water. There's no one set consensus of how much water a person needs to be healthy throughout the day. They can tell you how much you need to survive, but then that obviously needs more to have a healthy level in your body. Now you're saying, well, can't we just do these sports drinks and other things? And you could, but there's give and take. The sports drinks a lot of times have a lot of sugar in there. Do you really need to add a lot of extra sugar if you don't need to replace those electrolytes? Now, if you're working out for an hour, heavy, a lot of sweat, sure, you might need to replace the electrolytes. That could be beneficial then to grab something that is a sport drink. But if you're walking the dog for a half hour, you're not dripping in sweat. If you're doing a family bike ride, casually going to the park, you're probably not dripping in sweat unless it's 100 degrees out, then a different story. Again, this is all guidelines. It depends on what your circumstance is. You have to be able to judge it for yourself. But regardless, having your water from things like coffee or juices or sports drinks, sure, you can get water that way, but they all have added things going in your body. You're saying, well, 100% fruit drink, that's healthy. That's better than the ones that are 10% fruit, sure. But even with a 100% fruit drink, you're still having the sugars being added, which is not a bad thing if you have one. But if you're saying I'm drinking 2 or 3 fruit drinks in a day, then that sugar might start to add up. Having the actual fruit is healthier, because there's more nutrients and more roughage that way also. Saying coffee, I need my coffee. Okay, fine, everyone needs coffee sometimes. Some people drink coffee, some people don't. There's water in there, but the caffeine will have a different impact on your body. Sports drinks, I already mentioned the sugars. Now there is variation across the sports drinks. I'm willing to bet Gatorade, heard of that one, some big ones all over the shelves. Powerade, out there too. But do you ever think of Pedialyte as a sports drink? Probably not. You think of Pedialyte for kids, because that's what it's been marketed to. But take a look at the labels. Look at the Gatorade label compared to the Pedialyte label. It'll be interesting seeing the comparison of sugars and the comparison of electrolytes. Because a lot of times Pedialyte is lower in sugar, but higher in electrolytes. Just food for thought. Not saying ditch Gatorade, because Gatorade's a multi-billion-dollar company. They've got tons of research going into that. Just read the labels. Those nutrition labels are there for a reason. Make your decisions based on what's in the drinks. What flavors you like, what salt concentrations, what zinc concentrations, what electrolyte concentrations, what sugar concentrations. Just be aware of what you're using, that's all. All right, let's jump back into that water regulation. One of the biggest ways our bodies regulate water is through urine production. Now, I mentioned this earlier about the kidneys filtering all the blood. But do you know how much blood is filtered in a day? Your kidneys go through about 190 liters of blood in 24 hours. For comparison, you have about 5.5 liters of blood in your body. Just think about that. On average, the individual has 5 to 5.5 liters of blood. The kidneys filter 190 liters in a day. Your blood's being filtered over and over and over numerous times a day. Thankfully, you don't urinate 190 liters in a day. The average urination falls between 800 milliliters and 2,000 milliliters. That varies, obviously, depending on hydration levels. If you end up getting dehydrated, you fall towards the 800 milliliter side. If you're heavily hydrated and you're drinking a lot of water a day, you'll be up close to the 2 liter side. There's no one, here's the golden answer, because everybody is different. But you can judge for yourself. Looking at the coloration of the urine, towards the clear side, plenty of hydration. The darker the yellow, the more dehydrated the body is, because trying to conserve the water and have a higher solute concentration. There's a quick way of just double checking. Am I hydrated or do I need more hydration? Because all those electrolytes, all those ions, all those particles in the urine being excreted are things your body didn't need or you have excess of. Electrolytes. You need a certain level of electrolytes. Your body is going to filter them through the kidneys, but then the kidneys will reabsorb the necessary electrolytes. It's pulling all those things back in the body throughout the kidneys to make sure you have adequate levels. So your body's always doing these double checks to make sure you maintain the levels you need. They look at the salt concentration, the sodium, the chloride, potassium levels. And these are all being done by looking at the blood pressure in the arterioles of the kidneys, as well as something called the juxtaglomerular apparatus, or JGA. That monitors the salt levels in the blood in the kidneys. Now, because water follows salt, if the salt levels are off, the water levels are probably off also. So it's important to make sure that you're looking at the salt levels in relation to how the water levels are in your body. But that also comes into play. We have what's called the renin-angiotensin cascade. Now your kidneys produce renin, it's a hormone. That's going to trigger then a cascade from angiotensinogen to angiotensin 1 to angiotensin 2. And that can trigger what's called aldosterone, a hormone, out of your adrenal glands. Why am I saying all this? This is not anatomy. The reason being is that cascade controls your water levels in your kidneys. Aldosterone will help with retention of salt and retention of water in your bodies. So while you're monitoring those salt levels, monitoring those water levels. Those monitoring will then trigger that cascade for renin to angiotensin 1 to 2 and aldosterone to make sure you maintain the proper levels in your body. So you're trying to make sure that you keep the proper water, salt, electrolytes, ions. It's a huge balancing act across your kidneys. But the kidneys aren't alone. It's also hypothalamus, it's the adrenal gland, it's your blood for cardiovascular, all based on your nutritional intake of those nutrients, those electrolytes, and your water regulation. So it's quite complex there. We're not getting into all the details, just the basic top overview there. But let's start looking at some problems here. Let's say that system is working, but it just can't work well enough. There's something called water intoxication. Now, water intoxication isn't something very frequent. It's quite unusual, actually. It's where you have too much water. Now, there was a contest several years back. A radio had basically a contest for drinking how much water you can hold without urinating. This is basically referred to as the Jennifer Strange case, because unfortunately, she came in the contest, participated, but then later unfortunately passed away because of this. They were drinking water every 15 minutes, trying not to urinate, so basically keeping all this water in. She had gotten up to the point of about 2 gallons ingested of water in 2 hours. Now, think about that. 2 gallons. A lot of times the average person doesn't even drink 1 gallon in a day, much less 2 hours. By drinking that much water, and especially not allowing the urine to pass through, so the kidneys couldn't store it, they couldn't do anything. The water was in the bloodstream, causing a hypotonic condition. What that means is, by being hypotonic, the blood around the blood cells didn't have enough nutrients, didn't have enough ions. The blood cells then started having problems. They started rupturing. Unfortunately, that means she passed away. Now, I'm willing to bet most people here have not drunk 2 gallons of water in 2 hours. I don't even think I've ever drank 2 gallons of water in 1 day, much less in 2 hours. So hence why I said usually water intoxication is not very common, but it can happen. You gotta listen to your body. If your body is saying you're not thirsty, you don't necessarily have to drink massive amounts. Watch the urine. If the urine is dark yellow, you're drinking more. If it's perfectly clear, you're hydrated, doing good. Pay attention to your sweat. All helps out there. And it all helps you prevent dehydration as well. Now, unfortunately, dehydration is much more common. Dehydration can start with as little as 2% of your body mass of water being down. That's not a lot. 2% of your water, that's nothing. So what is dehydration? Dehydration is when your body's levels have a higher ion concentration in the fluid than necessary. Just you don't have enough water. The water dissolves the fluids, dissolves those ions. So the blood gets a little thicker, makes it a little harder to pump, but the overall idea is the ions are not in proper concentrations. By not being in proper concentrations, the rest of the tissues in your body can't function properly as well. Now that can go worse, and really bad. Unfortunately, dehydration gets to the point of dizziness, not feeling well, confusion, pushing into blacking out, coma, even death in extreme cases. Your body's hydration is so important, it's something you have to pay attention to at all times. In more extreme cases, that can get into heat stroke. Now, in heat stroke, it's characterized by a core body temperature greater than, depends on the source here, 103, 104, 105 degrees Fahrenheit. Depends if you want to look at the CDC, the Mayo Clinic, the Cleveland Clinic. There's no one consensus of exactly what the temperature has to be, but it's hot. If you've ever had a fever get up to 103, 104, 105, you know you're not feeling well. That's heat stroke. In that cases, your body just is not able to respond to the temperatures. There's not enough fluid, Sweating may completely stop. So if all of a sudden you've been sweating, and you stop sweating and it's still the same temperature out, you gotta get somewhere and get cool. You know you gotta get somewhere to help out. The best way to help heat stroke, get out of the environment you were in, someplace cool, start cooling the body down. Ice packs, cold washcloth, anything to cool the body temperature down. Increase hydration, need more water. Not necessarily electrolytes, because you might have enough, but the water to start with. You can always add in the electrolytes as you go through it. This could also be caused by extreme exercise. You're really doing a lot of heavy aerobic exercise. You're sweating, all of a sudden you just get too hot and you stop. That could be heat stroke also. So hydration, when it's not working, there are problems that can occur, and something can be major problems sometimes. But all this talk about hydration, we have to talk about the water itself. Back in 1974, the US Congress passed what's called the Safe Drinking Water Act. Now that was signed into law later that year by Gerald Ford, the president at that time. What that did is it charged the EPA, the Environmental Protection Agency, with setting guidelines of what should be and shouldn't be in our water. What levels of all different components are acceptable? How much of this ion or that ion can be in drinking water and still be safe? What levels of bacteria or viruses or protozoa can be in there and still be deemed safe? You don't want a whole lot, believe me. But this has helped improve our drinking water quality and reduce drinking water illnesses huge amounts over the past several decades. Now that's important because we need the water for our hydration. Helps provide more safety, more security, and more trust in the water that you're drinking. So hydration throughout your body, really, really important. So all this water regulation is something to think about and keep in mind. Until the next video.